Welcome back, everybody. We're still working with triple integrals. We can use triple integrals to find volumes of a solid if we just let the function equal 1. That goes in the triple integral. The solid, we need to have the equations that set it up, but we can do that. So in this problem, we're going to find the volume of the solid that's generated within the cylinder. X squared plus y squared equals 16. So that's a toilet paper roll tube or paper towel tube with the axis of z. We're going to cut it off below from z equals 1 and above from y plus z equals 4. So if I solve for z, I get 4 minus y is this line right here. Okay. So how do we do our integral? Clearly, z is going from 1 to 4 minus y. And now we got to choose to do either x squared plus y squared, x or y. And we're going to use, because now we've gotten rid of the z component, we're now just working in x and y. I ended up going with x first. So x is the square root of 16 minus y squared. We have a front half this side. That's our 16 minus y squared. And the lower boundary is the back half of the circle. The negative square root of 16 minus y squared. And finally, when y equals 0, we see that x squared equals 4, or x squared equals 16, so x equals 4. We're going from negative 4 to 4 for our x component. Or our y component, sorry. Set x equal to 0. Yeah, okay. So we got our integral here. We're using 1 as our function. First thing we have is a z. But z is 4 minus y minus 1. Gets us 3 minus y. That's pretty straightforward. Do the next part. We have no x in here, so we got 3 minus y times x evaluated from square root of 16 minus y squared to negative 16 minus y squared. So that's x at b minus x at a. But the negative, we got a negative here and we got subtraction, turns into a plus. So we're going to have 2 of those square roots. So I had 6 minus 2y. This is probably a little bit easier if we do a u sub. And I'm going to break the 6 off, do a separate integral for that. We got the separate integral for the 6. We do a u sub on this one. U equals 16 minus y squared. D equals negative 2y dy. We just get the square root of u in there. But when y equals 4 and y equals negative 4, u goes from 0 to 0. That integral goes to 0. So we just have 6 times the square root of 16 minus y squared dy from negative 4 to 4. This was sine inverse, or give us a sine. So this was from a formula table. I don't have this memorized. That's from a formula table where they do a squared minus u squared. And I have a equals 4 and u equals y. Square root of a squared minus u squared. That's the thing we plug in 4 or negative 4. You'll see when we plug in 4 or negative 4, this square root goes to 0 each time. So we really just have the 8 sine inverse y over 4. Still got the 6 out front. When we do 4, we got 8 sine inverse of 1. Where does sine equal 1 at pi over 2? And when we do negative 4, we got negative 4 over 4 is negative 1. When does sine equal negative 1 at negative pi over 2? So we evaluate this, we get 48 pi. Peace.